We're recording and everything. So yeah, go ahead and change this last one to a 9, okay? That was just for, stuff. And if I wanted to, could we just real quick plot some of these points, right? I'm going to make this -3, 0, and then we'll do 3, 6, 9, 12, and 15. So if f of -3 is 4, I can plot the point -3, 4. And then 0, 3. And then 3, 5. And so on. And then what I would like you to do is draw a function. It doesn't have to be a perfect function, but a function connecting all of those points, because that's what f of x is. So yours might look like mine. It might look different from mine. It doesn't really matter. How we feeling so far? All right. Now, what the trapezoid rule is just a different approach to integrating. It's a different kind of Riemann sum, okay? And so what we're going to do is, for each of these kind of sections, make a trapezoid. And the idea, I feel like we're about to get interrupted.
Spidey sense.
We were talking probability today, so I'm going to borrow some of these.
Okay,
guys!
Do you need anything else?
Best class ever! Who's staying in for next semester?
Uh-oh.
Oh gosh. Oh boy. Oh boy. We got some dropouts.
Is
Yates
Ian? Ian
Oh,
is,
you're
right?
out?
Yeah, sure is.
Oh, Yates. Okay, I'm sorry to interrupt. I got together with an old student of mine from New Albany who is now applying for med school at Ohio State. I tutored her in pre-calc and calc while she was at New Albany and I was here. And she's going to be a doctor. And she got through her AP Calc AB in high school. And she's like, that was the last math class I ever had to take, thank God. And she's going to be a doctor. So you guys know, there is hope, okay? There is hope. That 1152, she goes, I did not take math calc 2 because I didn't need it. If you need it, take it.
Y'all,
You're right.
Miss Lombardi,
Let's go.
guess what?
What?
This is the last lesson of 1151.
You guys, doesn't that make your heart flutter?
Makes my heart.
Yeah, that's what I mean.
I think I'm the one who feels the most relieved by this.
Totally. And you guys are like trapezoids? Well, we're down with trapezoids.
Yeah.
Now we have to do other things.
I don't know what the Simpsons rule is. That's the last one. I don't know what that one is. So good luck, have fun. I miss you guys.
Oh, you don't want to come teach Simpsons rule while I do the probability?
Ooh. Sure. We would have a lot of fun.
I left you my notes.
We would learn the Simpsons rule. We would make sense of it. We could. But, okay.
I got a textbook to help explain it.
Yeah, cool. Bye.
All right, y'all. Do you guys see how the trapezoid might be a pretty decent approximation of this area?
Yes.
Okay. So the idea is it considers that like diagonal thing. All right. Now, does anybody remember the formula for the area of a trapezoid? Go ahead.
Well, it's height times.
Okay, so are you guys with me that the height for this is the height of my trapezoid is actually the width in this particular case? Okay, so it's the height. Okay.
Isn't it height and then base 2 minus base 1?
Base 1 plus base 2,
Oh yeah, that.
which I'll just make that h over 2 if that's cool with you guys. Are we comfortable with this?
Yeah.
Does this feel slightly familiar?
Yes. I
Okay.
got a little too hard.
You guys, tell me.
Yes.
This trapezoid here. How would I find its area? 3 over 2. Okay, because the width of the trapezoid is 3. Divided by 2. Yeah? Times?
7.
Oh, instead of saying 7, can you tell me
4 plus 3.
4 plus 3? Okay, hold on.
Can I just bring the 1/2 up?
Yeah, can I make that?
Can you guys just chill for me for a second, please and thank you? You act like I'm the meanest person ever. Jiminy, I can't win today. All right, y'all. Next, what about this next trapezoid? This one.
3 halves.
So if I'm finding the area under the curve, I'm just going to add these, yes?
Yeah.
So it'll be 3 halves times
3 plus 5.
3 plus 5, okay? And then the next one would be 3 halves times
5 plus 7.
5 plus 7, and then 3 halves times 7 plus 1, and then 3 halves times 1 plus 2, and then 3 halves times 2 plus 9. Very good. And so the next thing I might point out is we have a lot of repetition here. In fact, any of those interior sides of my trapezoid are twice because they're part of 2 different trapezoids. And it's only those outside pieces that there's only one of them. Does that kind of make some sense? Okay, so if I wanted to, I could have rewritten this as a 3 halves on the outside. And then we did what? F of negative 3. And then we had 2 f of zeros. And 2 f of 3s. And 2 f of 6s. And 2 f of 9s. 2 f of 12s. Because the height of that trapezoid is just the value of the function. And then we just had 1 f of 15. I'll let you guys look at that for a second. Why did we use the 3 twice? Well, that's f of 0 twice, and that's just saying that this side, I should use the pointer. This side was used in 2 different trapezoids. F of 0 was the base of 2 of the different trapezoids. F of 3 is 2 different trapezoids. Okay? Does this kind of make some sense? Okay. So, and then, yeah, so and then what are we getting if we actually do this math? Like if I ask you guys, what does this work out to be? I'm sorry? 73.5?
If I input it correctly.
You did. You did. That's what I got. Because I have it right here.
Oh, yeah.
This was not one where I was going to fly blind. Yesterday, I flew blind. Flew blind?
Low.
Today, I think it would have been fine flying blind with this first half today. It's the second half that I didn't want to fly blind for, if you know what I'm saying. Okay. So essentially, as you guys really wanted me to do, we did 1/2 times 3. Are you guys with me that 3, why 3? Well, that was because the width of each trapezoid was 3. Okay? And the way we could have gotten that is we would have said, well, we're doing 15 minus negative 3. And how many total trapezoids did we have? 6. We had 6 trapezoids. And so we've kind of talked about delta x in the past as b minus a over n. That's going to continue to be the same, okay? So the trapezoid rule basically looks like this. That we have the 1/2, and then we have b minus a over n, and that's no different. That b minus a over n is just delta x, okay? So if we had to do this with an actual function, okay? My function, what would delta x be if I was doing this for 4 trapezoids? 3 minus 2 over for 4. So, to use the trapezoid rule, we're essentially going to do four trapezoids, starting with x0 and ending with x4. Okay? So, you guys, that b minus a is going to end up being over n is going to be 0.25.
Do you multiply the denominator by 2? Like, could that be 3 minus
We will. Yeah. But, like, as I'm trying to think of my x, like, what is f of x, I need to know what we are plugging in for each of those thingies. Okay? So, my first x would be 0. The left-hand side of my first trapezoid would be 0. This 0.25 is describing the width of that trapezoid, which is going to be 2.25, 2.5, 2.75, 3. Questions? Okay, so now if I want to find the integral from 2 to 3 of 2 over x squared dx, I'm not going to find the exact answer. We're making an approximation. Okay, we're going to do that 0.25 times divided by 2. So we had b minus a over n was the 0.25. So if I threw a 2 on the denominator there'd be a 2 in the denominator here. That's where that's coming from. Okay? Times 2 over 2 squared, 2 over 3 squared. My endpoints, I'm only using once. If I draw that picture, yeah? Okay? And then all of those interior ones, so these 3, how tall are they? They're f of whatever those values are. So I would do f of 2.25, which is really 2 over 2.25 squared. I'm not making this easy on myself here at all. So just that is this is f of x1. But because that would be the side of 2 different trapezoids, I have to multiply that by 2. So all those interior ones get doubled. And if we were to just kind of sketch that for a second, the function might look, let's see, 2 might look kind of like this. When we're talking about from 2 to 3. split up into 4 trapezoids.
Pretty accurate.
What did we get? What does our approximation work out to be? I got a 0.3351. Is that about what you guys got? So this one's f of x0. This is 2 times f of x1 plus 2 times f of x2 plus 2 times f of x3 times f of x plus f of x4. And that's where those are coming from. Okay. I'm definitely not flying blind on this part. Okay. All right, let's go ahead and look at this next one. So this is one method for approximating an integral. Simpson's rule is a different method for approximating an integral. Yeah. Perfect answer? No. It's still just an approximation, especially because we don't have the equation of f. Okay? Okay. The basic idea is you have your function, okay? And you're going to basically pick 3 equally spaced x values. So, like, these 3 x values essentially would define 2 trapezoids if we were using the trapezoidal rule. Okay? But these are not trapezoids. What we're going to use instead is use a parabola. So I'm going to kind of highlight this dotted parabola here. So if you have 3 points, there is exactly one parabola that goes through any 3 points. Okay? And so the idea being that because a parabola is curved, that area that's like not correct will be closer to the actual curve, is the idea behind Simpson's rule. And so whenever you have, excuse me, when you have a parabola, we have this like specific rule that all parabolas follow. So between any 2 points, the integral between 2 points on a parabola is equal to b minus 6 over a, b minus a over 6. But you guys, if I'm going from x1 or from x0 to x2, instead of b minus a, I can call that x2 minus x0. Is everybody with me so far? Okay. And P of A becomes f of x0 plus 4, and then P of A plus B over 2. You guys, A plus B over 2 in this case would be x0 plus x2 divided by 2. Are you guys with me that would equal x1? That x1 is the halfway point in between x1 and x2. Okay? So this becomes 4 times f of x1 plus f of x2.
Can you have more than like 3 x coordinates?
Well, so what would happen is, first of all, we would only use Simpson's rule for even number of partitions. And so the next one would become, so imagine I went from x2 to x4, I would have x2 minus x0 over 6. I'm sorry, x4 minus x2 over 6. Right? Plus, or times, okay? It would be f of x2 plus 4f of x3 plus f of x4. And we could, keep going depending on how many. And we only use Simpson's rules for even number of partitions. Does this make sense? So what ends up happening is, that we're going to end up with like that, I'm going to call it for right now, I'm going to call it the width of my partition. We'll talk about that in a little bit more detail in a second. And when you look at what we have, we're going to have f of x0 plus, I only have 4 f of x1s plus, but in this case, I'll have 2 f of x2s. And then I'll have 4 f of x4s. And then what would happen if I did another one? If I broke up into and added 2 more sections, right? I'll end up with 2 f of x 5s.
You accidentally wrote f of x4 for 4.
Oh, right. So this would be a 3. I'd have 2 f of x 4s, and then 4 f of x 5s, and then 2 f of x 6s. And then it would just kind of keep happening. It would repeat that way. All right, now, we talked about the width of the interval. So what is the width of this interval? It is x2 minus x0, yes? All right, so, and then, so and we divide, it ends up being b minus a over 3n. So the basic premise is that b minus a over n is the width of a partition. And then for every sum that we add together, we have 2 partitions. So we're going to times that by 2. And then the formula has us divide by 6. So hence we have b minus a over 3n. Looks way more complicated than it actually is. All right, so let's do some examples using Simpson's rule, and then we'll make, I think things will get a little bit clearer, okay? So if I'm attempting, this is the exact same one we did before, so let's go ahead and change that to a 9 as well, just so that we can have comparable answers here, okay? All right, so Simpson's rule says, out in the first part of my approximation is going to be b minus a over 3 times n. What's my n in this case? And this, what helped me is recognizing that in this case, that each of, I have my starting, and then I've gone 1, 2, 3, 4. That's how many partitions we have. We have 6. So times. So we're going to do f of x0. It's always going to start with f of x0. Okay? And so your endpoint, so that'll be, are you guys cool if I say 4? What's f of x0? It's 4, yeah? Plus. Then we're just going to alternate 4s and 2s until we get to the last number. So it'll be 4 times f of x1. So 4 times 3. And then 2 times f of x2, which is 5. And then 4 times f of x3. What is f of x3? 7. And then 2 times f of x4, which is 1. And then 4 times f of x5 is 2. And my last point, I don't multiply by anything because it's only being added in once. 9. Thoughts? What are we getting? $73 even? Cool, that's what I got. So did we get a similar answer when we did this question using the trapezoid rule? Let's try this one real quick. So if I do Simpson's rule here, what would my x0 be? 2. And if I have 4 partitions, I would have to go up by a quarter each time. So it's very, very similar to what we did on when we did this problem using the other rule. Okay. So my approximation would be 3 minus 2 over 2 times what? No, it wouldn't be 2. What would the denominator of this be? B minus A over 3n becomes B minus A over 3 times 4. Okay, so are you guys cool if I call this 1/12? And then we'll keep going. All right, then I need to do f of x0, which, what is f of x0 going to be? Yeah, I'm going to write it differently. I'm going to write it as 2 over 2 squared, but yeah, that works out to be 1/2. Then 4 times f of x1. Well, what's f of x1? It's 2 over 2.25 squared, right? We would have to do the... And then 2, f of x2 would be 2 over 2.5 squared. And then 4, f of 2.75 squared.
Why is it 2x squared? Should it just be 2 times 2.75 squared?
Where?
Oh, wait, I'm just misreading it. My bad.
So we have 4, 2, 4. That's right.
Yeah, no, I mistook your 0.75 for an x. It looks like a wobbly x.
My 0.7. Oh, got it. Hey guys, what are we getting? Three, 6.
Which one's closer?
I don't know. You know what we should do?
Just take the integral.
Is just take the integral. Yeah. So let's see. That would be the integral from 2 to 3 of 2x to the negative 1 dx. I'm sorry, 2x to the negative 2 dx. And then, let's see, wouldn't that be negative 2x to the negative 1, evaluated from 3 to 2? Does that feel right?
I'm just using my calculator.
Yeah. I get why you would do that, because it does feel like that might be a little bit easier. But at this point, I feel like I've committed.
Yeah, you've committed. I trust you.
You guys, that works out to be about 1/3, which is 0.3 repeating. So which one did a better job?
This one.
Yeah, so typically that parabolic estimation instead of the linear estimation is a little bit better.
I have a question.
I got an answer.
Why do we multiply both the coefficient by 2?
Because when we're doing this, like this parabola, it goes from x0 to x2, so it's 2 partitions.
Oh. Oh, yeah, okay.
Each parabola is 2 widths of these 2 partitions.
But we can just like add them all as one. Okay.
That formula, like this, accommodates for, like you only have one endpoint for each of the ends.
Mm-hmm.
And then the 2s and the 4s kind of accommodate for all of that adding and things being used more than once. All right, cool. Why don't you guys do those last 2 problems on the last homework? And while you guys do that, I will make you your cheat sheet of derivative rules. Is there any other things you would want on your cheat sheet to study? Say that again? Sure.
The derivatives and integrals of inverse functions.
They'll be on that cheat sheet for sure. For sure.
I think I figured it. Why would you do that?
Do we have to know like the original formal version of the derivative? Like the f and c minus
No,
f
that's
That feels like a reasonable thing for me to ask about.
Same for the
Does that feel like a reasonable thing for me to ask about?
What is it?
I'd rather you.
The limit definition of the derivative?
like
H
I
approaches
prefer-
0.
what about the h approaches 0?
That is the
To me, that's the formal definition of the derivative.
Wait.
Yeah.
So
f of
it's
x plus h minus f of x
isn't that
over h x? H?
No, that would the limit.
Yeah, it is h. But then you have like over 0. So
Yeah.
That's real